Hello friends, in this video I am going to explain you the problem on SFD and BMD. In the previous video also, in the previous video we have seen one problem on SFD and BMD. See, this problem is from December 2016, Mumbai University, for 10 marks. A beam of 8.5 meter long rests on a supports 5 meter apart. The beam carries load as shown in figure. Draw SFD and BMD showing all the important points. This is the problem from Mumbai University. You can see this diagram. A point is given here. This is C to A, then A to B 5 meter, B to D, that is 2 meter, C to A distance is 1.5 meter, A to B distance is 5 meter, B to D distance, that is 2 meter. From point A to B, uniformly distributed load is given, that is 50 kilonewton per meter. At point C, vertically downward force is given, that is 40 kilonewton. At point D, vertically downward force is given, that is 60 kilonewton. You can see the types of supports. At point A, hinge support is given. At point B, roller support is given. The contact surface is horizontal. See, this is the given problem. And for this beam, for this condition, you have to calculate shear force diagram and bending moment diagram. See, steps for each and every problem is same. First step is to calculate support reaction. The second step to calculate shear force calculation. Third one, that is to calculate bending moment calculations. And fourth one, important points like calculation for point of contraflexure. See, in this diagram, first of all, you have to draw the free body diagram. You can say at point C. Here you can see that at point C, vertical load is given, that is 40 kilonewton. At point A, there will be a two reaction, one horizontal, one vertical. But here we are taking only vertical, not need to take horizontal because we have to draw only shear force diagram. So vertical, that is RA. Here you can see the RB, that is also vertical. Got support reaction is having, roller support is having only one reaction, that is RB. Perpendicular to the contact surface, the surface is horizontal, so the reaction will be vertical. You can see RB. At point D, 60 kilonewton is acting. So two unknowns are there, that is RA and RB. By using the condition of equilibrium, we can find out the values of RA and RB. If you want to calculate the value of RB, then you can take moment at point R, at point A. If you will take the moment at point A, the RA component will be 0, because if line of action of force is passing through the same point, then the moment about that point will be 0. So the first condition of equilibrium, first step of this problem to calculate support reaction. So summation of moment at point A is equal to 0. Here we are taking clockwise positive. So mention clockwise positive. See, about point A, force into perpendicular distance, 40 kilonewton will move in the anti-clockwise direction. So minus 40 into perpendicular distance between C to A, that is 1.5. So into 1.5 plus, you can see this 50 kilonewton per meter UDL is given in between A to B, but you have to convert into the equivalent point load. So 50 into phi, that will be the intensity of equivalent point load, that is 50 into phi, and it will act at a center of this distance of AB. So phi divided by 2, that is 2.5, it will act here and it will move in the clockwise direction. So sign will be plus 50 into phi, 50 into phi, that is the equivalent point load, into distance 5 by 2 minus RB. RB will move in the anti-clockwise direction about A. So minus RB into phi plus this 60 will move in the clockwise direction. So clockwise direction, so it is plus 50 or plus 60 into distance 5 plus 2, that is 7. You have to take, every time you have to take perpendicular distance. So here 60 into 7 is equal to 0. There is only one unknown, that is RB. So you can calculate the value of RB. The value of RB is 197, is 197 kilonewton. The value is positive, so it is upward. You can see the value of RB is positive. Now, by taking another condition of equilibrium, that is summation of Fy is equal to 0, vertical positive, upward positive, downward negative. So here RA moving towards upward, that is positive, RB is moving toward upward, that is also positive, minus downward forces, minus 40, minus 50 into phi, because you have to convert into equivalent point load. So 50 into phi, UDL is given, so you have to convert UDL into point load. 50, that is the intensity of UDL, into phi, that is distance. So here you will get 50 into phi minus 60 kilonewton is acting vertically downward. So minus 60 is equal to 0. Now here we have the value of RB. You will get the value of RA, that is 153 kilonewton. So here we have the value of RB and RA. So first step is to calculate support reaction, that is RB and RA. After getting the value of RB and RA, the next and very important term is to calculate the values for support reaction. Shear force calculation, not shear support reaction. Next step is to calculate shear force calculation. The second step is to calculate shear force calculation. See, every time you have to consider given points while calculating shear force. The important thing, just to the left, just to the right, that concept is very important. Here you can see. At point C, at point A, at point B, and at point D. You have to start from left. After that, next point, that is A, B, and D. Accordingly, you have to write shear force at point C, just to the left, just to the right. At point A, just to the left, just to the right. At point B, just to the left, just to the right. At point D, just to the left, just to the right. Here you can see the sections, just to the left, just to the right, just to the left, just to the right. For B, this one is just to the left, just to the right. At point D, just to the left and just to the right. See, as we know how to calculate here, at point C, here, you have to consider all the left side forces of the section. So there is no any force See the cursor location. This is the section. Shear force at point C just to the left. There is no any force at left. So shear force at C, that is 0. Just to the left, that is 0. Here you can see the cursor location. That is very important. Just to the right. One force is there. At left side, you can see minus 40. So shear force at point C just to the right is equal to minus 40. After that, you can come at point A just to the left here. Consider only left side forces. So again, for A just to the left, minus 40 kilonewton. Now come at A just to the right, there is minus 40 plus RA. RA, you can consider left side forces. So for left side forces, minus 40 plus RA. So the value will be minus 40 plus 153, that is 113 kilonewton. Similarly, for at point B just to the left, you can see this section here. So minus 40 plus RA minus 50 into 5. The answer will be minus 137 kilonewton. Come at point B just to the right. So minus 40 plus RA minus 50 into 5 plus RB. Now the answer is 60 kilonewton. For D just to the left, again you have to consider all the left side forces. Minus 40 plus RA minus 50 into 5 plus RB. The answer is 60 kilonewton. And D just to the right, minus 40 plus RA minus 50 into 5 plus RB minus 60 is equal to 0. So here we have the value 60 minus 60, that is 0. You can see shear force at C just to the left is equal to 0. Shear force at point D just to the right is equal to 0. Now the next point, that is also very important point, bending moment calculation. See, after completion of this, you can draw the diagram of, see here you can see for C point, the values are 0 and minus 40. For at point A, the value is minus 40 and plus 113. For point B, the value is minus 137 and plus 60. For at point D, the values are 60 and 0. C to A, there is no any force, so line will be straight. From A to B, there is a UDL, so line will be inclined. You can see this line, inclined line. Now the next, from B to D, there is no any load, so line will be straight. This is the shear force diagram. You have to draw this SFD. You can draw this dotted line for the reference. It will be more easy to solve the problem. Now, next calculation is very important calculation, that is bending moment calculation. See, as we know that at end point, means at point C and at point D will be 0. So here just you have to calculate at point A and at point B. Here you can see bending moment at point A is 40 kilonewton is in hogging condition. So minus 40 into 1.5, that is the moment at point A. So you can see the bending moment at point A is equal to minus 40 into 1.5, that is 60 kilonewton into meter. You can see the bending moment at point B. Here at point B, you can consider either left side or right side. At right side, we have only one force, so we will consider right side. this 60 kilonewton is again in the hogging condition. So minus 60 into 2, that is minus 120 kilonewton into meter. These are the bending moments at point A and B. So according to this, you have to again draw the bending moment diagram. At point A, it is minus 60. At point B, that is minus 120 kilonewton into meter. Here 60 kilonewton into meter. So you can see here the straight line. So below this in the BMD, there will be an inclined line. In SFD, there is an inclined line. So there will be a parabolic curve. You can see in the diagram from B to D, there is a straight line. So there will be an inclined line. Minus, plus, and minus. Here in the shear force diagram, minus sign, plus, minus, and plus. Above the baseline, that is plus. Below the baseline, that is minus. During exam, you have to draw this type of diagram. Now, the important points are there. Position of maximum bending moment, where the shear force at xx is equal to 0. So to calculate this point, the important concept is there. See, here the shear force is 0. It changes sign positive to negative. We have to calculate this distance. From this to this, you have to calculate. So we will extend that line here and we'll consider that is x section. Here you can see the diagram. Here we have taken XX section. This distance is 40 kilonewton. This load is 40 kilonewton. This one is A. This one is the XX section. And shear force at XX is equal to 0. So minus 40 plus 153 minus, we have taken minus 50 into X. This distance is X distance. We don't have this distance. So minus 50 into X, because we have to consider that shear force. So minus 50, that is the intensity of UDL, into distance, you will get equivalent point load. So minus 50 is equal to 0. Answer will be 2.26 meter from A. So from this point, this X will be 2.26 meter from A. So maximum bending moment you will get at this point only. So here you can see minus 40. You have to calculate maximum bending moment at point XX. So minus 40 into X plus 1.5. This distance is X. This distance is 1.5. Do this correction. Plus 153. It will move in the hogging condition. So plus 153 into X minus 50 into X, that is intensity, into, it will act at a distance of X by 2. So into X by 2. So here 50 into X by 2 is nothing but 50 into X square by 2. So the answer will be 68.82 kilonewton into meter. That is maximum bending moment. Now you have this value. that is 62. This one is the maximum bending moment point. You can see here. Means whenever you will draw parabolic curve, you have to take maximum distance as a 68.82 here. And next one, point of contraflexure. As we know that where the bending moment at xx about xx is equal to 0, that is the point of contraflexure. You can see this diagram. This one is first section where the bending moment is 0. Here one more intersecting point, there will be a bending moment will be 0. So to calculate this, you have to extend this point on the this is very important point. You have to extend this point on the FBD. Here will be the section that will be XX. So see the cursor location. Just we are considering the point is here. So minus 40, that is a hogging condition, minus 40 into, we don't have this distance, means from A to this distance we don't have, that is X. So we are taking X distance. So X plus 1.5 meter. So minus 40 into X plus 1.5 plus RA is 153. The condition will be sagging. So 153 into X minus 50 into X by 2. But it will move in the hogging condition. So minus 50 into X square by 2 is equal to 0. Now in this equation, there is only one unknown, that is X. So we can calculate the value of X, that is 0.615 from A. You can see here. So you will get the value of X1. Similarly, you can calculate the value of X2. For X2, you have to extend this point here. And the remaining things are same like previous. You will get the point of contraflexure, that is X2 also. In the first step, we calculated support reaction. Second step, to calculate shear force calculation. In the third step, bending moment calculation. The fourth step, here we have taken position of maximum bending moment. Where the shear force is equal to 0, you will get the position of maximum bending moment. And now we have the value of maximum bending moment after that point of contraflexure. Where the maximum bending moment is equal to 0, that point will be your point of contraflexure. So here we have this point and this point. These are the point of contraflexures. So here we completed this problem. The next lecture we will see Another problem? Thank you.